with a section, a new section, and it's going to be called the alternating series test. And it also has in it questions called absolute convergence. So there are a fair amount of notes going to be done with this. Start with what is an alternating series and what is an alternating series test, I guess. And so this is 11.5 and alternating series test. Right. Normally I do series with AN, and I would do this with AN, except the book decides to call them BN. So here is, let's try that again. That's better. Here is an alternating series. What makes it alternating? It goes plus, minus forever. So examples of alternating series. Here's one. Here's another one. If you want to see what their formulas look like.
So are you writing that little plus and minus and then the ellipses? Is that the accepted way to write that?
Yeah, that's the kind of generic way that you get, say, and so on. I always think the 3 dots just mean and so on. They probably don't, but that's the notation that we use. And the reason we do a plus and minus is pretty obvious, right? Because we're trying to indicate, it alternates. So this one would go plus a fifth minus a sixth of eternity, right? This one, what's that, 4, 8, 16, that's a 16 there. Negative 132 plus 164 for the universe. This one would be 1 over n. To get a positive first, you'd have to use that guy. To get a negative first, you'd have to use that guy. There. You can check that out, but can you see these are examples of what is called an alternating series? Now, when a series is written down in this format, right? I'll call this question 1. I'll call it A and B. How about that? For A, the top one, Bn is 1 over n. And for the second situation, Bn is 1 over 2 to the n. So can you see in this generic form up here, Bn represents the formula part. And then alternating series always have a negative 1 to the n or a negative 1 to the n plus 1. So I've given you both situations. So, okay, that one says n, but couldn't it also say n plus 1 and it'd still be an alternating series? Right. Well, that's what an alternating series looks like. So when do alternating series converge? When do alternating series diverge? Well, here we go. If an alternating series, sigma n equals 1 to infinity, negative 1 to the n bn, right? If that alternating series has the following properties. It will converge. So an alternating series will converge, provided these 3 things are true. The BNs must always be positive. Because if the BNs are negative, won't that destroy the plus minus pattern? So a pure alternating series must always go plus minus plus minus. If you made some of these terms negative, wouldn't it cancel out with a negative that's there and change it in some way? So that's not allowed. Secondly, Bn must be decreasing. And lastly, the limit, the limit as n tends to infinity of Bn must be 0. If those three conditions are met, then the alternating series will converge. Okay, now, if the following are true, 1, if Bn is sometimes less than 0, you can't use a test. However, if Bn is greater than 0, but Bn is increasing, you can't use a test. If, however, it's greater than 0 and it's decreasing, but the limit as n tends to infinity of Bn is equal to a number, right? And that number is not 0, then the series diverges. So basically, as long as it's positive and decreasing, if the limit is 0, converges. And if the limit's not 0, it diverges. So it's actually a pretty straightforward test, isn't it? And the first two are just so you can use it. In fact, isn't the first two the same rule for an integral test? You got to be positive and you got to be decreasing, or you can't use me. So for most questions in the homework, will we just assume that that is true? It'll just save you a whole load of work. But when you do the test, will you prove it? Right, when you do physical tests, but in homework, you can skip by that. So let's give you some examples. I'm going to do 2 examples to start the show. I'm going to do one converger and one diverger, right? So suppose we have n equals 1 to infinity, -1 to the n plus 1, 1 over n squared. Let's look at that one. So in this question, the guy that the textbook is calling Bn is that guy. Okay, let's get the conditions out the way. I mean, sometimes the conditions are kind of obvious. Would you agree that as long as n is 1, 2, or 3, that 1 over n squared is positive? I mean, it's so obvious, I don't know how you could prove it, right? It's proof by inspection, right? I'm looking at it and I can tell. Right, now I'd like to prove that it's decreasing. The best way to prove it's decreasing is to just imagine it as a function, which I'm going to call L to the negative n to the negative 2. Find its derivative. Probably rewrite it in that form. Now, would you agree that provided n is 1, 2, 3, 4 forever, that the top is negative and the bottom is positive, so the whole answer is negative and therefore it's decreasing? And it's decreasing because its derivative is negative. Would you agree that's a pretty quick proof of decreasing? I found its derivative and then I discovered that its derivative is always going to be negative, at least for n equals 1, 2, 3, 4, 5, things like that. So the last part of the test is actually, let's find out what this cell is. So in this case, let's find out what that guy is. And sometimes, actually a lot of times, it's going to be dead easy. Would you agree that's just a brute force? Conclusion, converges. Right. Not the worst math in the world. I mean, typically step 1 and 2, you could imagine them being done, but isn't step 3 the killer, right? The one that decides. Okay. Now, in your homework, you'll probably be skipping by those and just focusing on that, because your homework would take forever if you had to do that all the time. But, you know, pick a couple just to keep your, you know, keep your hand in, right? You know, in case you forget that you have to prove it.
If you want to, could you also split it into 2 series, like the difference of 2 series?
Are you talking about one of the questions in the homework that's like a 1 over n cubed plus a half to the
Well,
n, something like that?
For this one, for example, couldn't you split it into like all the positive ones and all the negative ones?
No, I wish you could. And I like your thinking. Okay, let's prove why that's not the case, but it's a good question. So let me show you this guy. Now, if I write this guy out in full, he's actually this fella. And so if we used your logic, which does have a, you know, it does seem to be reasonable, what you're saying is that I should be able to collect all the positive ones, right? And take away all the negative ones. All I've done here is I've grouped all the negative ones together, right? And stuck a minus outside them. Would you agree that this looks like it should be equivalent to that, right? Now,
Yeah.
it take a little bit of argument, but can you trust me that that actually ends up being infinite? It's a 1 over 2n minus 1, and you could prove it using the integral. I can prove this one because it's half a harmonic and it's harmonic. Do you see what the problem with infinity take away infinity is? Is it's not guaranteed to be 0. But neither is it guaranteed to be a number. It could be infinite. This series actually converges. Even although it's made up of an alternating series, the fact that you add and subtract them makes a difference. This series, you can check it on your own, converges.
Could you sort of turn it into a telescoping series and show that the first term minus the second term, solve that, and then add the third term minus the fourth term? So that way you get like 1/2 plus, I think it's a 12th plus I think a 30th, and then prove it converges that way.
You'd have to come up with a formula for it, and I think it's probably not worth the work since the alternating series test does it so quickly. I'm not saying it wouldn't work, but it's just less power. Well, let's just do this guy, right? Bn is 1 over n. I'm going to do some really quick. Would you agree that that's always positive? Would you agree that it's also decreasing? A half to a third, right? So all I need to do is find out what that fella is, right, in a -1, clue it's decreasing. So all I need to do now is find that guy. Brute force it, 0. Oh, it converges. Did you say quick? The proof was, if you assume that the first 2 steps are obvious. Right. Let's show you a diverger. Oh, where shall I go with this one? Okay. Going to do some time things. Can you just assume that that is positive? That this guy here is positive? I think it's obvious he is. Can you trust me that if you do a bit of calculus, I can prove it's decreasing? Right. So all I need to do now is find this fella. Okay. What's the limit of that fraction as n becomes infinite? Agreed. L'Hopital it or divide top and bottom by n, you get a half. So conclusion. Oops. Almost said the wrong word there. If this isn't 0, which it isn't, it diverges. It's a pretty cool test, isn't it? It's pretty smooth. If you assume the first two bits are okay, all you need to do is find the limit. And if it's 0, it converges. And if it's not 0, it diverges. I'm
Can
going
you
to
show the previous page?
this one.
It was the example before this one.
Uh,
The
This one?
1 over n.
1 over n. Oh, that was 1 over n. Here it is.
Oh, I see it. Thanks.
So wait, if the 1 over n series is an alternating series, it converges. But
Yes.
if it's not, then it diverges.
Yes. Is that something that feels wrong?
Yeah, it's counterintuitive to me. But that
Yeah,
makes
I can
sense.
understand why it is. Let's just write them down. This is the harmonic series, right? And we know it's a P series, so we have proved that it diverges, which means that it adds up to infinity, essentially, right? What we're saying is that if you take the terms and you alternate them, that answer converges. If you want to know, it converges to natural log of 2 if you're interested in what the number is, but it converges. Well, did that help? Just telling you that it converges. If you think about why is that happening? This one's getting bigger, but it's getting bigger really slowly, but it keeps going on for infinity, so it actually gets infinitely large. Can you see the fact that if you're taking away bits, if you take away enough bits, can't you make the answer level off to a single sum? So where was it? Yeah, that's good. So now I want to show you an extra little cool bit. If I can find my original piece of paper. Here we go. This was and is the alternating series test. Essentially, the bit that tells you all the important stuff is right here, right? If the limit is 0, it converges. If the limit is something else, it diverges. Here's the extra bit for this one. If this fella converges, right? So you've already proved that it converges. And you use a partial sum to estimate its value. So let's say I use a partial sum Sn. Then the error is just the value of that guy. Okay. Show you what that means. Suppose we were going to do this fella. Now I know he converges, right? I've just trust me, right? I know he converges. Suppose I decide to use S4 to estimate what he converges to. Let's see what S4 is. Plug in 1 and you get 1 over 1 squared, take away 1 over 2 squared, plus 1 over 3 squared, take away 1 over 4 squared. Are you all happy about that's what S4 looks like, right? The first 4 terms. So I'm going to go to my calculator and just find out what that fella is. It's 1, take away a quarter. It's going to be add a 9th. And then it's going to be take away a 16th. And the answer that I get, I should be able to turn that into a fraction. And the answer I get is 115 over 144. And I'm saying that the error is just the next term. Well, B5 is 1 over 5 squared, which is 1/25. So we can say that this series adds up to 115 over 144, give or take 1 over 25. So let's round it off. It's 0.799, give or take 0.04. So not only do I know that that particular alternating series converges, don't I know what it converges to? It's 0.799, give or take 0.04. Would you agree we know pretty much what its answer is, right? I mean, if you add 0.4 to that number and you take away 0.4, doesn't that pretty much home it into a very small part of the world? Very small terms. That's very quick and very nice. Now, if it diverges, who cares what S4 is? It's going to be infinite eventually, so nobody bothers with those. You're only interested in converging. Any questions so far? Do we like alternating series? A little bit less work, maybe a little bit more intuitive. Yeah, kind of makes sense why it works, that kind of thing. So let's show you what some homework questions look like. This is question 1. 3/4, take away 3/6, plus 3/8, take away 3/10, plus 3/12, plus or minus whatever, right? Uh-oh, I don't have a formula. Right? Now, let's put the answer over here once we get it. This starts with a positive number, right? It goes positive, negative, positive, negative. If it starts with a positive number, use that guy. If it starts with a negative number, use -1 to the end. So that's just something you remember, right? If the series starts positive, use this. If the series starts with a -1, use the -1 to the end. Now the BN guy, all I'm interested in is 3/4, 3/6, 3/8, 3/10, 3/12. Would you agree the top is 3? And the bottom, say that again, Tim?
2n.
You are darn close to being right, but not perfect.
2n plus 2.
Yeah. The 2n was exactly the right start. Do you notice that you're adding 2 each time? And so that would generate that fella. Now, can we trust that this is positive and it's decreasing? Can we just assume that that's true because it is, right? Then don't I just need to find this fella? And that's Bn. And again, can we just brute force this one? And the answer is, oh, it converges then. And all you have is that little circle. Converges, diverges. And you pick that one, don't you? So don't cheat in your homework. Don't, because you get 5 guesses. Don't pick one if it's not that one, pick the other one, right? I mean, you got to get practice at this to make sure you know what you're doing.
Is the denominator supposed to be 2n plus 2 instead of 3n plus 2?
It's meant to be 2n. Oh, how did that happen? Yeah, there we go. I think my brain just picked a 3. Yes, it's 2n plus 2.
I have a question.
Yes.
If it starts at like n equals 5 or n equals 10 or something, does anything change with any of these rules?
One thing. The rule works perfectly the same. Sometimes
What
they
if it
avoid.
starts at like a negative number?
I don't think I've ever seen a series start with an n equals negative number, if that's what you're saying. But I've seen ones that go n equals 0. I've seen those. Bit weird, but I've seen them. And I've seen n equals 3s and 5s. Sometimes they miss the first couple of numbers because if you try to use them, the fraction ends up being like 3 over 0. Yeah, and you don't want a fraction looks like that. So I've seen them start at weird numbers. Doesn't matter for the test. N equals 10 or 2. It's the same test, the same conclusion. Because essentially, aren't you just missing out a few terms at the beginning? That's a finite number, so it can't affect the answer.
I remember earlier there was like an exception if it did something weird for the first few values. I want to say that was in one of the earlier tests. It wouldn't matter. Does that apply
Correct.
here too?
Yes. Yeah. We don't really care what it does for the first 3 or 4 terms, because some series zoom up and down. They're not actually decreasing, right? But we're flexible. As long as after the 8th term, it does what it's meant to do, we're cool.
It's also, since the first, you're not going to be able to make a series diverge with a finite number of terms. What
Yeah,
you have
you
in the
can't.
first term just doesn't matter.
Because 5 terms are going to add up to something, right? And
Mhm.
so whatever they add up to is not going to affect your conclusion.
Unless you divide by 0 or something.
But we keep well away from that. Yes, we keep well away from that. So let's not do that one. But you're right. Oh, okay, I think I'm going to show you some of these questions. It might be quicker as well than me writing them down from scratch. Here's an example. Where the heck am I? Oh, I was in the right place. Okay, this guy here, you see him? Bn has nothing to do with the negatives, that comes later, right? We're just focusing on the Bn here. Do you see it's 2/4 and 4/5 and 6 and so on, right? Now, I need a formula for this guy. It's definitely a fraction. Okay. So 2, 4, 6, 8, 10. What do you think belongs in the top? 2, 4, 6, 8, 10.
2n.
Great. Can you see add 2, add 2, add 2 means 2n? In this case, doesn't 2n do the job? I don't need to tweak it. Now, on the bottom, 4 to 5 to 6 to 7 to 8. Aren't you adding 1, adding 1, adding 1? That tells me, because I'm adding 1, that it's 1n. But don't I have to tweak it a little bit? So what's the bottom formula? The one that gets you the 4, 5, 6, 7, 8 thing.
Add 4.
And how much? You want
4.
to change that? Want to change that 4?
Oh no, yeah, I do. I want to change it to a 3.
Now we're good. Okay. Can you see that that guy is going to have a limited 2 and therefore it diverges?
So is there a reason we couldn't write it like 2n over 3 plus n? Because I think that makes more sense to me.
Yes, write it that way if it makes more sense to you. No.
Wait, is it increasing or am I thinking of it wrong?
Actually, it gets killed on the increasing as well. Yeah, right. But we just go straight to the limit. That kind of tells you anyway. You could, right enough, you could have a function that increases to 0. No, it could never increase to 0. Because if it increased to 0, wouldn't all the numbers have to be negative? And doesn't that break rule 1? That they all have to be positive, the BNs have to be positive. Yeah, just focus on the limit. I think that's the cleanest. It might get kicked out before then, but here we go. Would you agree this one is 1 over log n? I'll correct myself. It's not 1 over log n, but it is 1 over something to do with the log. What's the formula for that guy?
1 over natural log of n plus 3.
Okay. Would you agree that that's 1 over infinity? That's 0. So bingo, you've got a converger. Would you agree that's 1 over 4 plus 9n? What happens to that when it goes infinite? So isn't it a converger? Do you know a lot of alternating series? Can't you just look at them and know what is going to be once you've got a little bit of practice? Okay. Wouldn't this be 1 over the square root of n plus 4? What happens to that when n goes infinite? Yep. So isn't that a converger? Every time it goes to 0, you got a converger. If it goes to any other number that apart from 0, it's a diverger. Would you agree that diverges? Would you agree that diverges? What would that one do? Question 8.
It would converge.
Agreed. Do you want to convince other people?
The b of n there is 3 over e to the n, because it's to the negative n power, so put it on the bottom. And
Just brute force it?
yeah, because e to the n is infinite, and well, e to the n as n approaches infinity becomes infinite, and infinity on the bottom of fraction makes 0.
Nailed it. Any volunteers? Converging, diverging? Number 9.
Converging.
Agreed. Could you brute force it? Well, no, you couldn't brute force it. Divide top and bottom by n squared, the L'Hopital it, right?
Yeah, you could just do like 2n over 3n squared.
Is
And then go again.
L'Hopital an adjective of a verb? If I say you L'Hopital it, what is that? Come on, the English majors.
I think it could be both.
Yeah. You know, it's probably not even a phrase that's allowed.
I mean,
but
Googling something is a
L'Hopital.
verb.
Yeah, okay. But you know what I mean when I say L'Hopital, so we're good. Okay. What does n squared over 3 to the n get you? And more importantly, how are you going to prove it?
It's gonna make 0.
Correct. How are you going to prove it?
Well, there's probably many ways to prove this.
Okay.
First thing that comes to mind is, although it's messy, L'Hopital's, because the
Yeah.
numerator is going to become a finite number, but the denominator's not going to be. So
Yes, that would work. You could also do it. Remember that little weird list I gave you that says
well, that's how I
n to the n
normally
is
do
going to
it.
win, and n factorial, and you know, and then work your way down the food chain. Isn't 2 to the n bigger than n squared? So if there's a battle going on, you can do it that way. Which would be the second way?
So, question: if we, because I use that list, it's more convenient than proving it through L'Hopital's rule.
Yeah.
But is that acceptable on a test to say in the hierarchy of?
Yeah. All I would suggest is that you write that list somewhere.
Okay.
And then if you ever want to use it, say, look at the list that I've wrote down so I know what you're using. Yeah, mathematically that is valid. I don't want to do that yet. Okay. Good grief. As ugly as, are we doing any more? No, we're not. Okay. We have finished alternating series test. We are not finished in the sense we're not going to do any more, but we're finished in questions that only ask about the alternating series test. So now we're going to start the second half of that section, because it does have 2 names. And the second part of the name is an idea that's called absolute convergence. Technically, every series in the universe falls into 3 categories. Every single series. The first thing is that it just diverges. You know, series do that, right? They diverge to infinity, or they diverge in some way, right? There's no fixed value. Would you agree that the sigma of sine n, for instance, doesn't go infinite, but it doesn't go anywhere either, right? It just jumps around forever. Like sigma 1 over n, that is infinite, right? So diverges covers anything, right? Lots of different situations. Now we have what used to be called converges. And converges has got two flavors. There's one called absolute convergence. Just thought ahead there. Absolute convergence. And the other one is called conditional convergence. They both converge, right? So if you use the word converge, you're still telling the truth, right? They both converge. But for the family of series that converge, some are absolute convergence and some are conditional. So let's tell you what the difference is. A series is absolutely convergent if both the original series and the series that you would get if you made everybody positive both converge. So a series is absolutely convergent if the series converges, obviously, but here's the kicker. If you made everybody positive, it still converges. That's called an absolutely convergent series. So that's the first one. The second one is a series is conditionally convergent if that guy converges, but that guy diverges. Now, you might think that that would be impossible, right? How come if the first series converges, how could you ever get a situation where if you made everybody positive, it diverges? We did one today.
1 over
Remember?
n, right?
Yeah, 1 over n. Let's do the alternating series version of it, right? That guy, right? Now, just to remind you who he is, he looks like that, right? And haven't we already proved that that converges using the alternating series test? But if you make everybody positive, and typically making everybody positive tends to mean getting rid of that and replacing it with a 1. Can you see that this fella is a P series and diverges? So this converges, this diverges, which means that this particular series is an example of a conditionally. How about conv, so I don't have to keep writing the whole word. This is conditionally convergent. Right, let's show you an absolute convergent one. I want to make them nice and simple. Take that guy. He starts off with a -1, then you add a quarter, then you take away a 9th, and then you add a 16th, right? That's what it would look like. Now, can we just say that's an alternating series and it converges? You can tell just looking, right? It converges. Now, if you make everybody positive, do you see a P series here? 1 over n squared, isn't that a P series? It's a P equals 2. And doesn't that mean it converges? So that means this fella is an absolutely convergent series. So there are two kinds of convergent series, isn't there? Conditional and absolute. You might wonder why they bothered being pernickety. You would say, well, if it converges, who cares? You know, it converges. That's the important thing, right? It's going to add up to a number. The problem that they have with that was kind of discovered, I don't know who by, but a mathematician discovered something really scary about conditionally convergent series. If you take a conditionally convergent series and you rearrange the order that you add and subtract, you don't change the subtractions to adds or the adds to subtract, you just change the order. So you go like 1 plus a third plus a fifth. Then you go take away a half, take away a quarter, take away a sixth. And then you do the next 3 plus and the next 3 take away, and the next 3 plus and the next 3 take away. You would think that would make no difference to what the series adds up to. Unfortunately, weirdly, counterintuitively, it does. If you add them up in different ways, it adds the final thing based on the pattern that you gave it to add, makes the series add up to a different total each time. And that was bad news when they discovered that. Doesn't seem possible. But if you ever get into higher levels of math, they'll prove it to you. And it's really scarily weird. Because we like to think that math is logical, and it is. But isn't it logical in its math way? When you start doing common sense, it's not the same as math common sense. Right? There's two kinds of infinite. There's actually, just to be weird, there's an infinite number of infinities, right? Some infinities are bigger than others, right? Some are about the same size. Weird things happen when you do infinities. And if you change a series infinitely often, right? You change the way you add them, and you do that an infinite number of times. Can you see that weird things could happen? We just know that, and that's what screwed it up. The good news is, if a series is absolutely convergent, you can play about with it any way you like, and it still converges to the same number every time. So it's much more stable. So can you imagine that you were doing a series? If it was a conditionally convergent series, shouldn't you be a little bit worried about how you're writing it down in case there was a different way of writing the same series? Because if there was, couldn't you be getting a different answer because of that? And that's kind of the motivation behind it. And I think we are about done. So say your last name, space, first name. And while you're doing that, if you get attacked by a group of circus performers, what should you do? Go for the juggler first.
Ah.
Okay, bye-bye, guys. I'll hang about in case there's questions. Oh, you like that one, Tim? Go figure.
Yeah, I do.
And you never know what you lot are going to like. Tessa, was that a good joke? Oh, that was
I
a
forgot
thumbs
my
up.
mic was up.
Okay, any question? Tim, you got your situations covered, so we're good.
Heck
Okay?
yeah. Yeah, it went really good. It was
So, are you keeping on top of the work? How's it going that way?
I'm gonna have to rewatch those lectures again because although I watched them, and I was able to do the homework with some help from my neighbor who's a math major, I'm
Right.
probably gonna have to watch those again and then come to you and be like, hey, I have some small questions.
Not a problem.
So
Office
you'll
at
probably
10.
expect to see me in your office hours. Probably not today because I'm gonna watch them today.
Right.
Probably tomorrow or the next day when I'm like, okay, yeah, this is the stuff I don't understand.
Gotcha.
Do you know if I can still go on the homework and try the practice more like this one function even after the homework has already been turned in?
I don't know. Go and try it.
I'll give it a shot. All right. I did get the homework done, but I did have to have my neighbor. She has a degree in math, and like her thesis was actually on like the boundary functions of series or something like that. She explained it to me, and the problem is she's really good at them, and so explaining them is not maybe her forte.
Yeah, I know what that's like.
So, all right. Well, I appreciate it. I'm gonna go watch those right now, though.
Okay, bye-bye, Tim.
But thank you for the opportunity.
No problem. Rosie, you got a question, or Christian or Liam? Either of you three guys got issues?
I had a question about 11.3, number 12. I went to tutoring and they said it was a P series, but part of me thinks they were wrong because I think I asked you a question about this in class, about if you could just take the natural log of x out of the series and have it just be 1 over x squared. And then I think you said something about how you couldn't do that.
Let me see what we're talking about. Yes, you couldn't do it by pulling the log out. You're right. So this is the question 11 or 12. Which one are we talking about?
12.
12. So question 12 is this fella. Right. That guy. Agreed?
Yes.
Okay. Now I'm going to do this fella. And I'm going to do it by the direct comparison test. This fella here, right, is greater than or equal to that guy. Because a log of n is going to be greater than or equal to 1, provided n is, 5 or 7 or 10, whatever it takes, right? Actually 10. But it's true eventually. Now, what do you know about that series? That is a P series. And that's P equals 2, so it converges. Oh, now that I've done that, I'm going to have to go back to my question. I'm going to go this way. Now, n squared, I've kept them the same. I've got a log n here, and I'm going to put an n to the power of 0.1. And this is, you're going to have to trust me on this, but n to the 0.1 is bigger than or equal to log n, provided n is big enough. Prove that to you. If you look at the list, the hierarchy list, the weakest function in the world's a log. Then after that, it's the n squared, n cubes. Then after that, it's 2 to the n's. Then after that, it's the n factorials. And then after that, it's the n to the n. Now, n squared is just a placeholder for any positive power. So it could be n to the 0.1, and it belongs in that family. And anybody, as you go along this family, the direction is in size. So that's why I could say this is bigger than that. And now I'm going to change this guy to 1 over n to the 1 plus 1, and that is a P series. And it sounds maybe like I'm being nitpicky, but they have to be exact. The P series of 1.9, and that also converges. So that's how I would have proved that one. If I wanted to prove this using the where's it going? Using the direct comparison test. Does that help?
Okay. Yeah, thank you.
Okay.